Prefer to watch this in Hindi? You can find the link in the description below. Imagine a world where machines can learn, remember, and even think like humans. Intrigued? Keep watching to discover the groundbreaking science behind this reality. This year's Nobel Prize in Physics goes to John Hopfield and Geoffrey Hinton for their pioneering work in machine learning. Using tools from physics, they laid the foundation for today's powerful artificial neural networks. John Hopfield created a structure that can store and reconstruct information, much like our own memory. Geoffrey Hinton developed a method that allows machines to independently discover properties in data. These innovations have revolutionized how we interact with technology, from language translation to image recognition. But how did it all begin? Let's take a journey back to the 1940s. Researchers started to explore the mathematics behind the brain's network of neurons and synapses. Donald Hebb's hypothesis suggested that learning occurs when connections between neurons are reinforced. Inspired by these ideas, scientists began to build artificial neural networks as computer simulations. In the 1980s, John Hopfield introduced the concept of associative memory. Imagine trying to remember a rare word. You search your memory, and suddenly, it clicks. That's associative memory in action. Hopfield's network can store patterns and recreate them even from incomplete or distorted inputs. He used his background in physics to model these networks, drawing inspiration from magnetic materials. Hopfield's network saves images in a landscape of peaks and valleys, finding the closest match in its memory. Meanwhile, Geoffrey Hinton was working on a different approach at Carnegie Mellon University. He expanded on Hopfield's network using ideas from statistical physics, creating the Boltzmann machine. The Boltzmann machine learns from examples, not instructions, making it an early generative model. It can recognize familiar traits in new information, much like identifying a friend's sibling. Despite initial setbacks, Hinton continued to refine his models, leading to the deep learning revolution. In 2006, Hinton and his colleagues developed a method for pre-training networks, optimizing their performance. Today, deep neural networks contain millions, even trillions, of parameters, far beyond Hopfield's initial 30-node network. Machine learning is now used in various fields, from discovering the Higgs particle to predicting molecular properties. Physics has not only contributed to machine learning but also benefits from it, enhancing research capabilities. The ethical implications of this technology are widely discussed, as its applications continue to expand. John Hopfield and Geoffrey Hinton's work has truly transformed our world, making machines smarter and more intuitive. Their discoveries have unlocked the door for innovations we once thought impossible. As we look to the future, the potential of machine learning seems limitless. From more efficient solar cells to advanced medical diagnostics, the possibilities are endless. Thank you for watching. Remember, the future of technology is being written today. Stay curious, stay inspired.